Scenes of cities submerged by water, floating cars, and stranded people have become increasingly common in the news. Have you ever stopped to think about what exists beneath our streets that should prevent these tragedies? Today, we will reveal how systems that combat urban floods work, showing impressive technologies that many people do not even imagine exist. Stay until the end to discover how some cities are revolutionizing the way they deal with rainwater, while others continue to sink in problems from the last century. Urban flooding is one of the most complex challenges our cities currently face. With the increasing frequency of extreme weather events, the situation tends to worsen if we do not act intelligently. Let's explore how this vital but practically invisible infrastructure works, which determines whether a city sinks or remains safe during storms. First, we need to understand what causes flooding in cities. Nature has always had its own drainage system. When it rains in non-urbanized areas, water follows a natural cycle. Part evaporates, part is absorbed by the soil, feeding aquifers, and the rest slowly flows to rivers and lakes. It is a perfectly balanced system that took millions of years to develop. But when we build cities, we drastically alter this cycle. We replace permeable soil with concrete and asphalt. We channelize rivers. We occupy floodplain areas. The result? Water that was previously absorbed by the soil now quickly runs off impermeable surfaces, accumulating volume and velocity. A recent study showed that an urbanized area can generate up to 6 times more surface runoff than an equivalent natural area. The conventional urban drainage system was developed precisely to deal with this problem. Let's explain how it works at its different scales, starting with the most basic. Micro-drainage is the first level of the system, formed by structures we see in daily life: gutters, storm drains, and catch basins. These elements capture rainwater from streets and sidewalks, directing it to underground pipes. Many people don't know, but a single clogged drain can compromise an entire local system, causing flooding in several blocks. These underground pipes form a network that transports water to the second level, macro drainage. This larger system includes large diameter galleries, open channels, and, in some cases, channelized urban rivers. It is responsible for conducting large volumes of water out of inhabited areas or to temporary storage structures. And it is at this point that we come to a structure that has become increasingly common in large cities: detention reservoirs, popularly known as big pools. These enormous structures function as the city's water lungs, temporarily retaining large volumes of water during intense rainfall for gradual later release. The big pools are one of the most impressive examples of urban drainage infrastructure. They can be built on the surface, taking advantage of public areas such as parks that are temporarily flooded, or they can be colossal underground structures invisible to most people. A notable case is the G-CAN system in Tokyo, Japan, built to protect the metropolis from devastating floods. This gigantic underground system has 5 huge tanks connected by 4-mile tunnels at 164 feet depth. The main tank features 177 concrete columns, 59 feet tall, forming a space that looks like an underground cathedral. The system can pump 200 tons of water per second, redirecting excess to the Etagawa River when necessary. Impressive, isn't it? But even such monumental conventional structures have their limitations. The traditional approach, focused on draining water as quickly as possible, is no longer considered the ideal solution by experts. Why? Because it only transfers the problem downstream, causing flooding in other areas, besides overloading receiving rivers and streams. That's why in recent years there has been a paradigm shift in urban drainage. Instead of simply draining water, the modern trend is to adopt the concept of sponge city: absorb, retain, and use rainwater where it falls. This approach is known by various names around the world: Sustainable Urban Drainage Systems, SUDS, Low Impact Development, LID, Best Management Practices, BMP, or Green Infrastructure. Regardless of the name, the basic principle is the same: work with nature, not against it. SUDs are based on a fundamental tripod: controlling the amount of water, ensuring its quality, and providing amenity and biodiversity benefits for the population. It is an approach that transforms a problem into an opportunity, integrating stormwater management with urban planning and quality of life. Let's learn about some of these innovative solutions that are revolutionizing urban drainage around the world. Permeable pavements. Have you ever imagined a sidewalk or parking lot that lets rainwater pass through it? Permeable pavements allow water to infiltrate the soil instead of running off the surface. They can reduce surface runoff by up to 80%, in addition to filtering pollutants that would normally be carried to rivers and lakes. Rain gardens. These are depressions in the terrain filled with vegetation and prepared soil to absorb and filter rainwater. In addition to reducing surface runoff, they beautify the urban landscape and create habitats for local fauna, especially pollinators such as bees and butterflies. Green roofs. Vegetated coverings not only thermally insulate buildings, reducing energy consumption, but also retain up to 70% of rainwater that falls on them. In densely built cities where space at street level is limited, green roofs represent an opportunity to add permeable surfaces in previously waterproofed areas. Bioswales and infiltration trenches. These are vegetated channels that slowly conduct rainwater, allowing it to infiltrate the soil and remove pollutants through vegetation and microorganisms. When implemented along roads, they can replace traditional gutters and drains with significant environmental advantages. These solutions are even more efficient when combined in an integrated approach. In Hamburg, Germany, for example, a system was implemented that uses urban green areas as rain gardens and bioswales, allowing water to infiltrate the soil and significantly reducing the load on sewer systems. Another city that deserves mention is Portland in the United States, with its Green Streets program. The city transformed more than 2,000 locations into green drainage structures, managing to retain and infiltrate millions of gallons of stormwater annually, in addition to creating more pleasant urban spaces. Technology has also revolutionized the management of drainage systems. Water level sensors, weather radars, and automatic stations allow real-time monitoring of conditions throughout the system. In South Bend, Indiana, USA, sensors installed throughout the drainage network send constant data to a control center, which can remotely adjust the operation of detention basins and gates, optimizing the entire system. Early warning systems are another crucial technological advancement. With the use of real-time meteorological data and advanced hydrological models, it is possible to predict hours in advance where and when flooding will occur, allowing preventive evacuations and mobilization of emergency teams to critical areas. We can imagine the future of urban drainage as an intelligent combination of gray infrastructure, pipes, pumps, reservoirs, and green infrastructure, nature-based solutions, all managed by intelligent systems that constantly learn and adapt. A truly climate change resilient city needs to integrate water into urban planning, not treat it as a problem to be hidden underground. The challenge is enormous, but solutions exist and are being successfully implemented in various parts of the world. The question that remains is, what are we waiting for to adopt these approaches in all cities? Change begins with awareness. As citizens, we can push for public policies that prioritize green infrastructure, demand that new developments adopt sustainable drainage principles, and even implement small solutions in our own homes, such as cisterns for rainwater collection or rain gardens in the yard. Even simple actions like not littering on streets or cleaning drains near home before storms can make a difference. Remember that a single clogged drain can flood an entire street, affecting dozens of families. Rainwater doesn't have to be our enemy. With proper planning and smart technologies, we can transform it into a valuable resource for our cities. Instead of increasingly larger structures to drain water away, we need systems that allow us to live harmoniously with it, taking advantage of its benefits and minimizing its risks. Now that you know the secrets of urban drainage, help spread this knowledge. Share this video, talk about the subject with friends and family, demand sustainable solutions from local authorities. Together, we can build more resilient cities where catastrophic floods become only memories of the past. Let's now explore a real case that demonstrates how the integration of these systems can transform urban reality. The city of Singapore faced serious problems with flooding due to its tropical climate, with intense and frequent rainfall. In addition, its high urban density and scarcity of land made it difficult to implement conventional large-scale solutions. The answer was the Active, Beautiful, Clean Waters program, which completely transformed the city's approach to water management. Concrete channels were renaturalized, creating winding streams with natural vegetation that purify water and absorb excess flow. Reservoirs were integrated into the urban landscape as parks and leisure areas. Rainwater collection systems were installed in virtually all buildings. The result? An 80% reduction in areas affected by flooding, even with the increase in rainfall intensity in recent years. And most impressive, the rainwater captured today supplies about 40% of the city's water needs. What was a problem became a valuable resource. It is essential to emphasize that the success of a drainage system depends not only on advanced technical solutions. Governance and citizen participation are equally important. In many cities with exemplary drainage systems, there is a clear administrative structure with well-defined responsibilities and sustainable financing mechanisms. Some might argue that such solutions are too expensive to be implemented on a large scale. However, economic studies show the opposite. A cost-benefit analysis conducted in several cities revealed that for every dollar invested in sustainable drainage systems, between $4 and $7 are saved in repair costs for flood damage, not counting indirect benefits such as real estate appreciation, improvements in public health, and creation of leisure spaces. Another little discussed aspect is the ability of these systems to adapt to climate change. While conventional systems are sized for historical events that may not reflect future reality, sustainable systems are inherently more flexible and robust in the face of climate uncertainties. In closing, it is important to mention that the transition to more sustainable systems does not need to occur all at once. Many cities are adopting a gradual approach, implementing green solutions in parallel with the maintenance and optimization of existing conventional systems. The important thing is that each new urban project is an opportunity to move in this direction. If you like this content, don't forget to subscribe to the channel and turn on notifications so you don't miss our next videos about engineering and urban solutions. See you next time.